Welcome to MRL. In this learning session, we will be learning about a very important quadrilateral known as parallelogram and its properties and also special type of parallelograms. Now let us understand as to what is a parallelogram. A parallelogram is a quadrilateral in which the opposite sides are parallel. In parallelogram ABCD, AB is parallel to DC and AD is parallel to BC. So therefore ABCD is a parallelogram. So it's very simple. In a quadrilateral, if opposite sides are parallel, then it is a parallelogram. Now properties of a parallelogram. We'll study the properties of a parallelogram in terms of sides, angles and diagonals. Now let us understand the properties in terms of sides. Now in a parallelogram ABCD, the opposite sides are parallel. That is AB is parallel to DC and AD is parallel to BC. And in a parallelogram, the opposite sides are equal. That means AB is equal to DC and AD is equal to BC. Now in terms of angles, the opposite angles of a parallelogram are equal. That means angle A is equal to angle C, angle B is equal to angle D. The adjacent angles of a parallelogram are supplementary. That means angle A plus angle B is 180, angle B plus angle C is 180, angle C plus angle D is 180 and angle D plus angle A is equal to 180 degrees. Now in terms of diagonals, there are two diagonals AC and BD. It is a quadrilateral and therefore there are two diagonals, rather there are two pairs of opposite vertices and therefore there are two diagonals in a parallelogram, that is AC and BD. The diagonals are unequal. Please remember this. The diagonals of a parallelogram are unequal. The diagonals bisect each other. That means the diagonal AC and BD bisect each other. It means that the point O is the midpoint of both the diagonals, or OA is equal to OC and OB is equal to OD. Remember that. And the diagonals also form pairs of congruent triangles. These two diagonals divide the parallelogram into pairs of congruent triangles. Rather, triangle AOB is congruent to triangle COD, triangle AOD is congruent to triangle COB and so on. So please remember that the diagonals of a parallelogram divide it into pairs of congruent triangles. Now about the special parallelograms. The special parallelograms are rectangle, rhombus and square. So let us learn as to what is a rectangle and why it is called as a special parallelogram. A rectangle is a parallelogram in which one angle is 90 degrees. It means that a parallelogram ABCD becomes a rectangle if one of the angles of the parallelogram is 90 degrees. Remember that. And also if a parallelogram has its diagonals equal, actually in a parallelogram the diagonals are unequal. If the parallelograms become equal, then it is a rectangle. So therefore parallelograms becomes a rectangle under two conditions. One, when one of the angles of the parallelogram is 90 degrees, or when the two diagonals of the parallelogram are equal. So now let us understand the properties of a rectangle. Now again in terms of sides, in terms of angles and in terms of diagonals. Now in terms of sides, as we know, rectangle is a special parallelogram, but natural, the properties of parallelogram are applicable here. Therefore the opposite sides are parallel and the opposite sides are equal in a rectangle. In terms of angles, all the angles are equal to 90 degrees in a rectangle. Angle A, angle B, angle C and angle D are equal to 90 degrees and the sum of the adjacent angles are supplementary, or the sum is 180 degrees. That means angle A plus angle B is 180, B plus C is 180, C plus D is 180, angle D plus angle A is also 180. Again the properties of parallelogram are applicable here. Now the diagonals of a rectangle. Now rectangle has two diagonals. Now we remember this, diagonals are equal. So in a parallelogram, if diagonals are equal, it becomes a rectangle, and therefore in a rectangle the diagonals are equal. Diagonals bisect each other. Diagonals form pairs of congruent triangles. As we know, these are the properties of a parallelogram. So these are very important properties of rectangle. Please remember these properties. The next important special parallelogram is rhombus. Now rhombus is a special parallelogram. rather a rhombus is a parallelogram in which a pair of adjacent sides is equal. It means, what does this mean? It means that in a parallelogram ABCD, if a pair of adjacent sides, if I take the pair of adjacent sides as AB and AD, if they are equal, then it becomes a rhombus. So the simple definition is, or simple understanding is, that a parallelogram becomes a rhombus if a pair of its adjacent sides are equal. Remember that. Now coming to the properties of rhombus, again we will study the properties of rhombus in terms of sides, in terms of angles, and in terms of diagonals. Now in terms of sides, as we already know, it is a parallelogram, therefore the opposite sides are parallel, and the opposite sides are equal, rather all the sides are equal in a rhombus. So remember, in a rhombus the opposite sides are parallel but all the sides are equal. Please remember that. Now in terms of angles, the opposite angles of a parallelogram are equal and the adjacent angles are supplementary. Again, that is the property of a parallelogram, because rhombus is a special parallelogram. Now coming to the diagonals, it has two diagonals, very important. It has two diagonals. Diagonals are unequal. The diagonals are unequal. Please remember, the diagonals are unequal. Diagonals are perpendicular to each other. That means diagonal AC and BD are perpendicular to each other, and diagonals bisect each other. That means O is the midpoint of both the diagonals. Diagonals form pairs of congruent triangles, and both the diagonals form four congruent triangles. If you see the triangle AOD, it is congruent to the remaining three triangles formed there. Therefore a rhombus is divided by the diagonals into four congruent triangles. Please remember, this is a very important property of the rhombus in terms of diagonals. The next important special parallelogram is a square. We already know what is a square. A square is a quadrilateral, already we know that, but a square is also a parallelogram, rather a special parallelogram. A square is a parallelogram in which a pair of adjacent sides is equal and one angle is 90 degrees. So very interesting it is. In a parallelogram, if one pair of adjacent sides are equal and one angle is 90 degrees, then it becomes a square. So this is a parallelogram, a pair of adjacent sides are equal and one angle is 90 degrees, so that parallelogram becomes a square. So therefore a square is a special parallelogram. Remember that. Now coming to the properties of a square. In terms of sides, again the opposite sides are equal here because it's a parallelogram, and all the sides are equal. So please remember this, all the sides are equal. And it's very interesting to know that all the sides of a square are equal, all the sides of a rhombus are equal, but the only difference between a rhombus and a square is in a square all the angles are equal to 90 degrees. That means rhombus becomes a square if the angles of a rhombus are 90 degrees. And also the diagonals of a rhombus are unequal, but the diagonals of a square are equal. Therefore a rhombus becomes a square if the diagonals are equal. Remember this. These are some basic differences which we have to remember. Now coming to angles, all the angles are equal to 90 degrees, as it is very clear, all the angles are equal to 90 degrees here. Adjacent angles are supplementary. Adjacent angles are supplementary. That means again the property of a parallelogram, that is angle A plus angle B is 180, B plus C is 180, C plus D is 180, D plus A is 180, and all the angles are equal to 90 degrees. Very easily it can be proved. Now the diagonals, it has two diagonals. Diagonals are equal, diagonals are perpendicular to each other, diagonals bisect each other, diagonals divide the square into pairs of congruent triangles. As we know, there are again four congruent triangles in this also. So please remember, a square is we can even say a square is a special rhombus rather. So remember this. These are the properties of a square. Here I have taken a theorem which proves the properties of a square. The theorem states the diagonals of a square are equal, bisect each other, and are perpendicular. So very important, the diagonals of a square are equal, bisect each other, and are perpendicular. So let us understand this theorem and also understand the properties of a square. Now we are given a square ABCD. We are given a square ABCD. AC and BD are diagonals which intersect at point O. Now we have to prove that the diagonals are equal. That means AC is equal to BD. And also we have to prove that the diagonals bisect each other. Rather, O is the midpoint of both the diagonals. Rather, we have to prove that OA is equal to OC and OB is equal to OD. And also we have to prove that these diagonals AC and BD are perpendicular to each other. Rather, I have to prove that angle AOD or angle COD is 90 degrees. So let us see how to prove this. A very easy proof, and let us understand it. Now let us consider the two triangles here, triangle BAD and ABC. BAD and ABC. BAD and ABC. In triangle BAD and ABC, AD is equal to BC because they are opposite sides of a square, and in a square you know that all sides are equal. And AB is common to both the triangles. Angle BAD and ABC, rather angle A and angle B, are 90 degrees. Therefore, by side angle side congruency criteria, these two triangles BAD and ABC are congruent. And if two triangles are congruent, we know that their corresponding sides are equal. Therefore, AC is equal to BD. That is what I have proved here, and that is the first proof that the diagonals of a square are equal. Now let us go to the second proof to prove that the diagonals bisect each other. So let us consider two triangles again here, triangle AOD and triangle COB. I have taken here two triangles, triangle AOD and triangle COB. In triangle AOD and triangle COB, we know that angle 1 is equal to angle 2 because AD and BC are parallel and AC is the transversal. Interior alternate angles are equal, and please remember angle 1 is equal to angle 2. Similarly, angle 3 is equal to angle 4, AD is equal to BC, opposite sides of a parallelogram. Therefore, by angle side angle congruency criteria, we have triangle AOD and triangle COB congruent. So we have two triangles congruent. If two triangles are congruent, then their corresponding sides are equal. Therefore, OA is equal to OC and OB is equal to OD, and that is what we have proved. And by that we have proved that the diagonals of a what we call square bisect each other. That is the second proof. Now we have to prove that AC is perpendicular to BD, and a very simple proof again. Let us consider two triangles again, triangle AOD and triangle COD. I have taken two triangles here, AOD and COD. In triangle AOD and COD, we know that OA is equal to OC, just we have proved it, and we know that OD is common to both the triangles, and AD is equal to CD. That means all the three sides of the triangle AOD and COD are correspondingly equal. Therefore, by triple S congruency criteria, these two triangles are congruent. That is, triangle AOD is congruent to triangle COD. If two triangles are congruent, there as you know, the corresponding angles are equal. Therefore, angle AOD and angle COD are equal, but AOC is a straight line, rather AOC is a straight angle. Angle AOC is 180 degrees. AOC is 180 degrees. That means angle phi plus angle C is 180. But we know that angle phi and angle C are equal, just we have proved it. Therefore, angle phi plus angle C is equal to 180, but angle phi is equal to angle 6. Therefore, 2 times angle 6 is equal to 180, or angle 6 is equal to 90 degrees, or angle AOD is equal to 90 degrees. That is, if angle AOD is 90, it means that AC is perpendicular to BD. That is what is the proof of the two diagonals being perpendicular to each other. This is how we prove the important properties of a square. Similarly, the properties of rectangle, the properties of rhombus can be proved very easily. So please follow this theorem. Try to apply this basic knowledge to prove the properties of rectangle, properties of rhombus, very important properties for application in geometry and calculations in geometry. Remember this, note down in our book for your future reference. Okay, thank you.